The sine function is a function, of course, that maps angles to a number that is either a ratio of sides or a point on the unit circle. And we'd like to consider the inverse of that function. The inverse sine function, this is the thing that will essentially reverse the direction for us. In other words, instead of plugging in an angle, we're going to get out an angle. So I'm just going to look first at this picture here and kind of show you where this function is going to come from. First of all, inverse functions actually only exist for functions that are one-to-one or that pass the horizontal line test. In other words, any horizontal line that you draw can only cross the graph once in order to have an inverse function. Obviously, here we can see that this horizontal line that I just drew crosses multiple times. In fact, it crosses an infinite number of times because this wave just continues forever. And so the sine function on its own does not actually have an inverse. And so we need to do a little bit of work to make it into a function that has an inverse. And what we do is we simply restrict the domain of the sine function so that this horizontal line will only cross in one place. And that's between these two spots right here, between negative pi halves and positive pi halves. Okay, and then we get this portion of the sine curve, okay, and any horizontal line will only cross this portion of the curve once. Now with that function then comes, with this restriction, we have an inverse function. So let me just point out a couple things. So this inverse sine function that we're talking about comes from the sine. So normally we say sine of some angle, and I'm going to do an example here. Sine of, say, pi over 2. Pi over 4. Sine of pi over 4 is the square root of 2 over 2. And the inverse sine function, which we actually have a couple of ways of notating it, we have sine with this little superscript of a -1. Don't think of it as an exponent because that's not what it is. And it sends this root 2 over 2. Okay, so sine inverse of root 2 over 2 is equal to the angle pi over 4. Now, this is one way of notating it. Another way of notating it is actually it's called the arc sine. The arc sine of root 2 over 2 is equal to pi over 4. These are the exact the same thing. They just are different ways of notating it. So in general, we can say this sine inverse of x is the same thing as arc sine of x. They're just different ways of notating the same thing. Now, what's important to note is that when we are plugging a number into the inverse sine function, we're looking for the angle that gives us that. But because of this restriction that we placed, it's only going to give us the angle between negative pi over 2 and positive pi over 2. So there are actually a lot of angles whose sine is equal to root 2 over 2. But the inverse sine will only give us one of them, the one that's in this range here between negative pi over 2 and pi over 2. So here's a graph of the inverse sine function. You can see really that it's just the sine curve, but it's been flipped over the line y equals x, which is where we get inverse functions, the graphs of inverse functions. And you can see that the domain here is between -1 and 1, which is the same as the domain, the range of the sine function. And then you can see that the range of the inverse sine is negative pi over 2 to pi over 2, which is, of course, the restricted domain that we placed on the sine function in order to get an inverse function.